Welcome back. So this is the final section of 5.3, solving trig equations. Now, the only major difference between this section and the ones that you've been working on already, it's the restriction. So you know how we've been restricting it from 0 to 2 pi normally? But now we're going to not restrict it, so it's going to be over all real numbers. So we're looking for every solution. As these are periodic functions, then you know that they go on forever and ever, and we are looking for every single solution that this equation is true. So we do the normal thing. For example, here, I can see that there's a sine squared and a cosine. That means I only want it in one trig function, right? So we're going to change to sine squared x because I know that's going to be 1 minus cosine squared x. Okay, now they're all in cosine form, which is nice. Now I only have cosine to worry about. Now when I multiply this in, I get 2, I'm going to multiply that in, so I'm going to distribute. So it should be 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Now when I simplify all that, I get 0 equals 2 cosine squared x minus 3 cosine x plus 1. So again, here I go, what the factor, right? What the factor? All right. And I factor this sucker out. And when I factor it out, I get 2 cosine x minus 1 cosine x minus 1. All right, just make sure that you factor that correctly. So here, when I solve this guy and this guy for 0, I get cosine of x equals 1/2, cosine of x equals 1. All right, so if I were to do 0 to 2 pi, here's what I would end up with. My solutions are x equals, pi over 3, and 5 pi over 3, and 0 because of that guy, right? That's more 3 solutions if it was from 0 to 2 pi. However, now, what if my solutions are over all real numbers though? Something's changed because these values will repeat. How often do they repeat? So we're going to talk more about that. But for now, we know that cosine is 1/2 at pi over 3 and 5 pi over 3, and cosine is 1 at 0. So we state this, x equals pi over 3. So we're going to set it up. 5 pi over 3, x equals 0. Okay, I know that we don't have to write the 0, but you'll see why. How often does cosine repeat? Well, every 2 pi, right? But every real number, so n. So again, n is all integer value, okay? So every 2 pi it repeats. Every 2 pi it repeats. Every 2 pi it repeats. So we have to state in this format for the answers for over all real numbers. Okay, now those are easy when you have an x that's not just single x, right? That means your usual cases, okay? Let's move on to this guy right here. Solve 2 cosine 3t minus 1. It's slightly different, but same, okay? So the first thing we're going to do first is solve it like you always do. So you get 2 cosine 3t equals 1, and you get cosine 3t, right? Sorry about my handwriting, equals 1/2. Okay, so now you have to think in your head. Think. When is cosine? If cosine was written like this, well, I guess I shouldn't write like that. I think I should write it this way better. Okay, what if cosine is theta? When is it 1/2? Is what you're thinking. Cosine theta is 1/2, and you're thinking theta is 1/2 when it's pi over 3 and 5 pi over 3. Okay, so you got that in mind. So if your solution, so let's do the third step now, okay? So that means if your solution was from 0 to 2 pi, it would be this. 0 goes from t is less than to 2 pi, correct? Okay, but what if now, look. It's over 3t though, right? 3t, we have 3t. That means what? It goes from 0, not t, but 3t. That means we have to multiply everything by 3, 6 pi. So in our original solution from 0 to 2 pi, it would be these two cases. For t, but we have 3t, so it's 3t and 6 pi. That means we'd have like triple number of solutions, right? So think about that case. So that means we have this. If it was from 0 to 2 pi, it would be 3t, right? 3t is equal to pi over 3. 3t is equal to 5 pi over 3, right? Which means t would be pi over 9, and t would be 5 pi over 9. So that would be from 0 to 2 pi. That would be our solution. And you'd be like, yeah, I'm done, woohoo, okay? From 0 to 2 pi. Okay, but now it's over all real numbers, right? Oh, wait a second. Okay, but it would happen every pi over 9 and 5 pi over 9, okay? But now let's look at over all real numbers. So this is the case where it gets a little bit tricky dicky. So we got 3t is equal to pi over 3, our original. 3t is equal to 5 pi over 3, right? So I'm going to rewrite that again. Sorry about that. 3t is equal to 5 pi over 3. But how often does this happen? Again, it happened every 2 pi. Every 2 pi. So n is all integer, right? Okay, so that means we have to divide everything by 3 here. Everything by 3. So that means for this first case, we get t is equal to pi over 9 plus 2 pi over 3n. T is equal to 5 pi over 9 plus 2 pi over n. And I know that you're realizing something about this 2 pi over 3, comparing it to 3t here. Remember the frequency of 3? That means the period of this function is equal to 2 pi over b, right? So it's 2 pi divided by the frequency, and that's why these came along. Okay, and this is our solution over all real numbers right here. Okay, but you know how you can use this right here to find all your solutions from 0 to 2 pi? Because this is not it, right? There's a way more, and we'll talk about that in class, all right? All right, good luck, bye!